Welcome back, guys. Today we're going to be covering section 12.3, Mass-Mole Stoichiometry from your CK12 packet. So anytime you're doing Mass-Mole Stoichiometry, you're going to be doing a lot of calculations, okay? So you need to remember how to do molar mass, and you need to remember how to do mole ratio, because those are the two topics that you're going to need, or the two skills that you're going to need in order to be successful um, in this section. Okay. So do you need nails? Anytime you're building or you're constructing a building or you're adding on to your house, you're gonna need lots of nails. So who's gonna help me with the introduction?
When you're doing a large construction project, you have a good idea of how many nails you will need. But when you go to the hardware store, you don't want to sit there and count out several hundred nails. You can buy nails by weight, so you determine how many nails are in a pound. Calculate how many pounds you're on your way to begin building. While the mole ratio is never present enough, so geometry calculations amounts of substance in the laboratory are most often measured by mass. Therefore, we need to use mole mass calculations and with mole ratios to solve several different types of mass-based geometry problems.
You got it, girl. Wow, that's a hard word to say, and you took it like a champ. All right, so let's say Miss Alexia, or I don't know, let's just pick on Oscar, because he seems like he's like the construction type of guy. So let's say Oscar's helping his dad build an extra room in the back of his house, or his dad's man cave or whatever. So, the first thing that Oscar and his dad are gonna do was they're gonna go get lumber and they're gonna go get nails, right? Because those are one of the basic items that you need when you're building. So while Oscar's dad is looking at the lumber to see how much he needs to buy and what width and all that stuff, his dad tells Oscar, "Hey, Oscar, we're gonna need 500 nails. Go to the nail section and go bring me 500." So the first thing that Oscar's gonna do is, well, he's not gonna sit there and count out 500 nails. That'll be very tedious, right? And it'll be very time consuming. Oscar is gonna be smart. He's gonna be like, he's gonna count, and he's gonna get a scale, and he's gonna be like, okay, well, let me figure out how many nails are in a pound. And let's say he figures out that there are 100 nails that for every 1 pound. So he's gonna be like, okay, so if I need 500, that means I need 5 pounds of nails. And that's gonna be a lot easier for Oscar to handle, rather than him waste a lot of time counting out 500. All right? Because Oscar's smart that way. So he measures out his 5 pounds and he heads on out, and he goes and he helps his dad build his man cave. So stoichiometry works the same way. If we're working in the lab and we measure out a certain amount in grams, well, it can get very complicated when you're trying to change that, or trying to change from grams of compound A to grams of compound B, or moles of compound B. So he's going to do some shortcuts, right? He knows molar mass and he knows mole ratio. Mole ratio was the first type of problem that we did when we started covering stoichiometry, excuse me. And you guys know molar mass from when back earlier in the semester, when we were changing grams to moles to atoms. So both of those skills you already know. Mole ratio, I can easily help you remember that. But molar mass, let's make you do some extra practice. So let's check out your first paradigm, or I'm sorry, let's talk about mass to mole problems. So anytime you have a type of problem where you're converting mass to moles, the first thing they're going to do is they're going to give you the mass of one substance. And let's call that substance compound A. So you have grams of compound A, and from this, you need to change it to moles of compound A. So the way you're going to do that is you're going to use molar mass, right? And then once you change grams of A to moles of A, well, you're going to use the balanced chemical equation and mole ratio in order to change moles of A to moles of B. And that's just, it's a two-step process. That's all it is. Okay? And it says here, from this, you're able to determine the amount of moles of another substance that will either react with or be produced from the given substance. So mass of your given, that's like grams of compound A. Then you're going to change it to moles of compound A. From there, you're going to go from moles of compound A to moles of compound B. And it says here, the mass of the given substance is converted into moles by the use of molar mass. Then the moles of compound A, which is your given substance, are going to be converted into moles of the unknown, which is compound B, using the mole ratio. And the mole ratio comes from your balanced chemical equation. If you don't have a balanced chemical equation, then you got to balance it yourself. But for today, I believe all the equations are already balanced for you. So half of the work is done. But like I said, before we go into our practice, you need to remember how to do molar mass. Okay? So that's your first Pear Deck question. And I know it's been a while since you've done molar mass, so I'm going to help you along. So anytime you're doing molar mass, the first thing you need to do is you need to list the elements in the compound. In our compound, it says, what is the molar mass of methane, which is CH4? So we got two elements, carbon and hydrogen, right? Carbon and hydrogen. So I'm going to make a list. Here's my list. And the second thing to do is to list, well, how many do you have of each? How many carbons? How many hydrogens? So you're going to go back to the formula and you're going to look, okay, what's the number that comes after carbon? What's the number that comes after hydrogen? If there's no number, it's always a 1. If there is a number, well, that's what it is. So for this example, how many carbons and how many hydrogens are in this compound, in this formula? Can you tell me that, guys? Look at the formula. Oscar, how many carbons? Look at the formula. How many hydrogens? Very good. Miss Diamond is already putting that carbon is a 1. Okay. What about hydrogen? Oscar, Diamond. Oh, very good. Thank you. 4. Now that we know how many there are, we need to use the atomic mass for each element and multiply so that we can get the total amount of carbons, or the total mass of all the carbons and all of the hydrogens. So I'm going to put times, and we're going to go to the periodic table, and we're going to look for the atomic mass of carbon and hydrogen. So if you remember, carbon is element 6. It's over here at the top right of our periodic table. I don't know if you guys can see that right here. Hydrogen is over here on the left, element number 1, 1.0079. And we're going to make sure that those numbers get rounded properly. 12.01 and then 1.01. And we're going to multiply. Carbon is 12.01. Hydrogen is 1.01. So 1 times 1201, that's easy. 12.01. 4 times 1.01, you might need a calculator for that. But I do have some very smart people that might be able to do it in their head. What would that be, guys? 4 times 1.01. What do you think? 4.04. Excellent. I hope the rest of you guys are following along. And remember, the final step in doing molar mass is to always add them up. 12.01 plus 4.04. That's easy math. What would it give me? What would it give me, Oscar? What would it give me, Mario, Galexia, Jeremiah? What's my total? Get your calculators. I know it's close by.
1.05.
Correct. Yeah, this is easy math and you don't really need a calculator, but it's always available in case you do. That is the molar mass of methane, 16.05 grams per mole. And we're done. Any questions on molar mass? Any questions? All right, let's go back into the pear deck. So anytime you do stoichiometry, it's all about practice, practice, practice. The more you practice, the better you understand what's going on. So here's your first sample problem. It says here tin reacts with hydrogen fluoride to produce tin to fluoride and hydrogen gas according to the following balance equation. And then you have your question. How many moles of hydrogen fluoride are required to react completely with 75 grams of tin? All right. And I'm going to go into Jamboard so that we can tackle this problem. All right. So remember, always identify what they're giving you. Okay. So I don't know if you guys can see this right here, 75 grams of tin. And they're asking you to change your grams to moles of hydrogen fluoride. So when we're in grams of tin, that's compound A. Grams of tin, and they want moles of hydrogen fluoride. And then you can go into the equation and circle the same information. Which one is tin? Which one is hydrogen fluoride? Well, remember, the symbol for tin is SN. Hydrogen fluoride is HF. So now that we have all the information that we need from the problem, from the reaction or the equation, now we're ready to start. So we're going to start with our 75 grams of tin. Okay, and what are we going to do with it? I don't know. Let's go over to our diagram and let's recall if I'm in grams and I need to change it to moles. Remember this diagram? Remember the diagram? So if you are given gram, you will always divide it by the molar mass in order to change to moles. If you're given moles going to grams, the opposite is true. You will take your moles and multiply by molar mass. See what I mean by the opposite is true? First, we were dividing by molar mass. Now we're multiplying by molar mass. Okay, so now we have our diagram. We know what to do in order to go from grams to moles. We know we have to divide. And we need to divide by the molar mass of tin. So we're going to go into the periodic table, right? We're going to go into the periodic table. We're going to find the atomic mass of tin. And if you look at the formula, there's only one of them. So whatever the atomic mass is for tin, that's also your molar mass. Element 50. Everybody see element 50? Here. Element 50. 10. SN. It weighs 118.71. 118.71. All right, let's check it out. So we're going to divide by 118.71 grams per mole of tin. All right, get your calculator out. I know it's a decimal, but what is my decimal? 75 divided by 118.71. Get your calculator out. Get your calculator out. What is it? I know it's 0 point something. You tell me what the answer is for this first part. 75 divided by 118.71. What do you think, guys? Yes, that's the number I got. 0.63. And now we have changed grams to moles of tin. So anytime we're doing mole ratio, we need to draw a line, a times and then a line. Because dimensional analysis is the only way to change moles of tin into moles of hydrogen fluoride. So I put times, a line, and then I draw my arrow to help me remember where moles of tin need to go in order to cancel. So where do moles of tin need to go? On bottom. So we're going to put here moles of tin. And so that means moles of hydrogen fluoride needs to go on top. So according to the reaction right here, how many moles of tin, how many moles of hydrogen fluoride are reacting here? What's the number in front of tin that you don't see? What's the number for tin that you don't see?
1.
A 1. And where does it go? Top or bottom?
Bottom.
Very good. So we're going to put the 1 on bottom. And then how many moles of hydrogen fluoride? Look at what I circled. How many moles of hydrogen fluoride do you see in that reaction? HF. 2. Thanks, Miss Diamond. So now the only thing that's left is to remember, well, what do I do mathematically when the numbers are all on top? What do I do mathematically with the 0.63 and the 2? Multiply. Very good. So let's do it, Miss Diamond. 0.63 times 2. What you got? One point something. What's my answer? There it is. Oops. 1.26 moles of hydrogen fluoride. And we're done. What do you think? It's not hard. You can say it's time consuming, but I wouldn't say it's hard. And you can see the answer here on the pear deck, 1.26 moles of hydrogen fluoride. Their setup looks a little bit different, but essentially it was the same thing. 75 divided by 118 times 2. Exactly what we did. And we got the same answer, 1.26. So your second pear deck question is it's the same type of question. It's still a mass to mole stoichiometry question that says a combustion reaction for methane is shown above. How many moles of water are produced from 50 grams of methane? Here's our problem. So circle what they're giving you. They're giving us 50 grams of methane. What are they asking us for? Moles of water. All right. Methane is my CH4. My water is H2O. And I'm changing this guy to that. So I've identified all the important information from our question and the reaction. Half the work is done. So we're going to start with our 50 grams of methane. And we're going to divide it by the molar mass of methane, which was our first pair deck question. I believe Jeremiah said that it was 16.05 grams per mole. That's the molar mass. That's what I need for this problem. So I'm going to put 16.05 grams per mole. So what is it? 50 divided by 1605. What'd you get? Oscar, I haven't heard from you today, Oscar. 50 divided by 1605, sir. Yes, that is what I got. Well, actually, 3.12 if you round correctly. Yeah, but that's the same thing I got. So then you're going to put a line, 1 times, and then a line, and then you're going to draw the arrow to help you remember how to cancel methane. So I'm going to put moles of CH4 and then moles of water on top. Okay, so now look at the reaction. How many moles of methane? How many moles of water? And where do they go? Waiting for my little ones. Oh, sorry. My bad. How many moles of methane? What's the number in front that you don't see? What's the number in front that you don't see? A 1. Top or bottom, Miss Diamond? Where does the 1 go? On bottom. Very good. Be careful. So on bottom goes the 1. And how many moles of water? Everybody see? 2. Very good. So now the only thing left to do is to multiply. Always remember, multiply the top first, then divide it by the bottom, but the bottom is a 1, so you don't really have to do that. So what's 3.12 times 2? Oh my god. You got it. Very good, Miss Diamond. Moles of water. And we're done. I told you, the more practice you do, the easier it becomes. Now, mass to moles is not the only type of problem you can do. You can also go backwards. You can start with moles of compound A and end in grams of compound B. It just depends on what they're asking. It's the same 2-step process. But instead of starting with molar mass, then mole ratio, it's going to switch. You're going to start with mole ratio, then molar mass. Okay? And I'm going to go straight into it because it talks about the same thing. How you have to use molar mass in order to change moles to grams, and how you need to use mole ratio in order to go from moles of A to moles of B. That's all it says here. So let's go straight into the practice so we don't waste time. It says here hydrogen sulfide gas burns in oxygen to produce sulfur dioxide and water vapor. What mass of oxygen gas is consumed in a reaction that produces 4.60 moles of sulfur dioxide? Okay? So we're here, and here's our sample problem. We're still treating it the same way. We're still circling all of the information that we're going to need. Okay, so let me go in here. Here's my 4.6 moles. Here's my mass of oxygen. SO2 is right here. Here's my oxygen, and I'm changing this guy to this guy. Right? Okay, so now we're starting with mole ratio. 4.60 moles of SO2. So we're going to put a 1 underneath it. We're going to put times and then a line. And then we're going to draw our arrow. Same process from last time. Instead of doing it as the second step, now we're doing it as the first step. So where does that 3 go? Where does the 2 go? Well, first I need to follow the arrow with my units. My unit is moles of SO2. So then that means moles of O2 need to go on top. Done. Okay, so is it 3 over 2 or 2 over 3? You tell me. Is it 3 over 2 or 2 over 3? What's your understanding of this, guys? 3 over 2. Very good. Very good. Wrong. Why? Well, look at the unit. I have oxygen here. Where's oxygen? Over here. So I'm going to put 3 over 2. Very good. Now, mathematically speaking, I'm still multiplying, and whatever my answer is after I multiply needs to be divided by 2. Calculator time. 4.6 times 3 divided by 2. Excuse me, what did you get? I got the hiccups now. If you multiply 4.6 times 3 and divide it by 2, what do you get? This should be an easy one for Jeremiah to figure out. Oh, very good, Ms. Diamond. 6.9. That's what I got. Okay, so then we're going to put 6.9 moles of SO2. And then we're going to go back to our diagram that we drew earlier. Because we're not going to divide again. What are we going to do? Remember, dividing by molar mass was in order to change grams to moles. But we're not doing that right now. Right now, we're starting with moles going to grams. So that's going to take a different method. And you could see here, we need to multiply by the molar mass. All right, so let's go back to our sample problem. And we need to figure out, and it's not of SO2, it's of O2. My bad. It's of O2. We canceled out SO2. So then what do we need? We need the molar mass of oxygen. And you'll recall there's 2 oxygens, right? So 2 times the atomic mass of oxygen, which if we look it up on our periodic table right here, element number 8 is 16, right? 16. So 2 times 16, that's easy math. Grams per mole, right? Grams per mole. And instead of dividing, we need to multiply. And then we'll be able to get our final answer. All right. Let me get my handy dandy calculator. 200 and something. Yes, ma'am. That is the correct answer. 220.8 grams of O2. What do you think, guys? The more you practice, the easier it gets. All right, there's the answer, 220.21. They rounded. It's all about sig figs. We're not so concerned about sig figs. Your last pair deck question is about the combustion reaction of methane. And it's asking how many grams of methane are produced from 3 moles of water. Okay. So here's our 3 moles of water. Right? So let's circle everything that we need. Moles, we need to change it to grams. This is methane, this is water, and I'm actually going this way. Okay. So if I start off with 3 moles of water, H2O, I need to do dimensional analysis to cancel out moles of water and change it into moles of methane. So I'm going to put, the arrow reminds me that water needs to go on bottom. Methane needs to go on top. This one should be really easy. Okay, according to the reaction, should I have 1 over 2 or 2 over 1? What do I do? Look at the reaction and tell me, is it going to be 2 over 1 or 1 over 2? Very good, Miss Diamond. You're on fire today. 1 mole of methane for every 2 moles of water. And you can see the numbers up here. Here's my 2 moles of water. Here's my 1 mole of methane. That's where she got it from. So remember, always multiply across and then divide down. So 3 times 1, 3 divided by 2. That's easy math. But I'll bust out my calculator just in case. Did everybody get that? 1.5? Is that what you got, Miss Diamond? 3 divided by 2 is equal to 1.5? Oops. And then I need to multiply by the molar mass. And I think earlier we said that the molar mass of methane was 16.05. What's my final answer? Around 25 is the answer. What is it? What is it specifically? Very good. That is correct. 24.08, right? Because we got to round correctly grams. Okay. So in summary, calculations involving conversions of mass to moles and moles to mass are described. Your review questions. In the first problem, what would happen if you multiply grams of tin by the molar mass of tin? Why is a balanced equation needed? Does the physical form of the material matter for these calculations? Okay.